reflection, and rotational symmetry. Consider an isosceles triangle. Is it symmetrical? Yes, it is symmetrical. If we draw the line of symmetry of the isosceles triangle, we get two symmetrical parts of the triangle. We get two identical parts. If we flip one part over the other part, then the first part will completely overlap the second. Therefore, we can say that this triangle is symmetrical. The symmetry is called reflection symmetry. Do you know why it is called so? This is because if we keep one part of this shape against a mirror along the line of symmetry, then we see the reflection of this part in the mirror. The reflection and the part outside the mirror make the complete shape. Do all the objects show reflection symmetry? No, all the objects don't show reflection symmetry. Let's observe this shape. This shape doesn't show reflection symmetry. Let's rotate this shape along the center point. Rotating a shape along the center point means rotating a shape like this. Let's rotate. What do you observe? We get the same shape after a complete rotation. This means it has rotational symmetry. A shape is said to have rotational symmetry when on rotating the shape along the center point through an angle, it appears the same as the original shape. If we rotate it around some other point, say this, then it will rotate like this. A shape will rotate differently depending on its point of rotation. We notice here that on rotating the figure, it coincides with the previous image only after a complete rotation. A complete rotation means rotating it by 360 degrees. Let's count how many times a figure looks exactly like the original figure on rotating at an angle. The figure right now is at 0 degrees. After rotating the figure at various angles, we find that it looks the same only at 360 degrees. Since this shape looks the same only at 360 degrees, its order of rotation is 1. The number of times a figure looks the same on rotating it by 360 degrees is the order of rotation of that figure. Now, let's find whether the following shapes have rotational symmetry or not. If yes, then what is the order of rotation? Let's start rotating them one by one and simultaneously